Okay guys, we're going to continue chapter 1 and we're going to move on to section 1.2. We're only going to spend one day on this because the next section will really kind of take our time with it because the next section we can do more stuff more analytically. But we're going to do 1.2, which is finding limits graphically and numerically. We're going to really focus just on the graphical part. Alright, so we're going to make sure we can estimate a limit using numerical and graphical approach and learn different ways to a limit can fail or exist. For our class, we are not going to worry about the formal definition of the limit. Don't really need that for us. Okay, so introduction to limit, what they are. So we're going to sketch a graph of this equation, x cubed minus 1 over x1. And for all other values other than x equals 1, you can use just your standard graphing technique. However, at x equal 1, it's not clear what to expect because when we plug in 1, we get 0 over 0, and that does not exist. Okay. So if we want to find out where that would look or where that would be, what we could do is plug in all the values into a graphing calculator, and we can approach the point 1 from the right and from the left. And as you guys can see, we'll pick x values to plug in that get closer and closer. So you can see we get 0.999 and 1.000. As you can see from the right and from the left, they are both going towards 3. So what we can say is that the limit as x approaches 1 of f of x equals 3. Now keep in mind that f of 1 still does not exist. We cannot say it equals 3, we can just say as the limit approaches it equals 3. And so you guys can see graphically here what's going on. It looks like a parabola, and we'll talk about why in the next section, why it looks like a parabola. Well, what we can see, it goes along the graph, but then there's a hole right at that spot at 1, 3. And we can find exactly where that point is using the limit. And so yeah, just like I said before, the limit of f of x as x approaches 1 equals 3. We cannot say that f of 1 equals 3, but we can say the limit as it approaches 1 equals 3. Now, what we want to do, so this basically leaves into the informal definition of a limit, which is what we'll go on, because we're informal. If f of x becomes arbitrarily close to a single number L, like in this past case 3, as x approaches C or x value from either side, and it's got to be both sides, the left and the right side, we say the limit of f of x as x approaches C is L. So we can't say f of C equals L, but we can say this equation. So we have another function here. We have x over all this, and if we plug in 0, you can see if we plug in 0, we're going to get 0 over 0, which does not exist. So we'd have to go through and try to evaluate. The easiest way to evaluate where the limit is to use a graphing calculator and plug in values that get closer and closer to 0. So try 0.001 and negative 0.001. And you guys can see the chart. When we plug it in, it gets closer and closer and closer, 1.9995, 2.005. So we can say the limit as x approaches 0. We can write out f of x, or we can write out the equation. I just like to use f of x because that crazy equation was pretty crazy. Equals 2. And you can see we got it right there. Alright, now reasons why that limits fail to exist are for a couple reasons. Say we have this equation here, the limit as x approaches 0 of absolute value of x over x. Now if we were to graph this, you can see that all positive values it would equal 1, all negative values it would be negative 1. Now there would be no existing value at 0 because just like before we'd have 0 over 0. Now, the limit fails to exist because coming from the left, it's going towards -1. Going from the right, it equals +1. These limits do not go to the exact same value, so we can say the limit does not exist. And if you remember that scene from Mean Girls, this is pretty much what's going on. The limit does not exist. I should put that in the video right now.
Contestant, find the limit of this equation.
Calling somebody else fat won't make you any skinnier. Calling someone stupid doesn't make you any smarter. And ruining Regina George's life definitely didn't make me any happier. All you can do in life is try to solve the problem in front of you.
The limit is -1.
Oh, crap. I lost.
That answer is incorrect. Now, we are in a sudden death. If Miss Heron can answer this problem correctly, we have a winner.
Limits. Why couldn't I remember anything about limits? Limits. That was the week Aaron got his haircut. Oh, God, he looks so cute. Okay, focus, Katie. What was on the board behind Aaron's head? If the limit never approaches anything, the limit does not exist. The limit does not exist!
Our new state champions, the North Shore Mathletes.
Alright, yes, the limit, since it doesn't approach the same thing, it does not exist. Katie Heron told us all. Alright, so basically there's a couple reasons, or a couple different scenarios why limits would not exist. What we just talked about, first part, the f of x approaches different numbers from the right side of c than approaches the left side. So if it doesn't go to the same part, it doesn't exist. The other part is that, part 2, f of x increases or decreases without bounds. So what that would look like, for example, 2, say we have a function, and we'll talk about specifically what kind of functions, but we have a vertical asymptote. And you can see here, this is a great drawing, but as the function goes up, it keeps on going up and up and up, and this side keeps on going up and up, and we could basically say it's going towards infinity, but infinity, we don't assume it is a real number. You can't count an infinity amount of chickens in a farm. It just goes up and up and up, so we can't say the limit exists, because we don't know where infinity ends. The third one, we won't really get into, it's kind of difficult, but this would be an oscillating function. So what that'd be, if we have some kind of harmonic function that starts off slowly, but as we get closer and closer, let's say to 0, it just gets up and up and up and just gets like crazy back and forth, and then come. Now there is a pattern to this, but since the function gets so crazy and gets back and forth quicker and quicker and quicker, we basically can't say it exists because it's just moving back and forth so quickly. So here's like an example problem you guys will see from some of the homework. We have different places here. Let me just label some of them. So I labeled the x values just a, b, and c, just completely arbitrary points. Now there's a couple things. We can basically say that the limit does not exist at the point, at B and C, because they are going both in opposite. Well, you can see these are both going to unbounds, and these are going to opposite directions. So the limit does not exist. But the limit, as x approaches a, we could say is about what, 1, 2, 3.5. But what we got to be careful of is that even though the limit exists for a, f of a is that point right there at 0. So sometimes you could have a limit that is different from the actual point. So you got to be careful with that. Alright, if you're having any troubles with this, let me know. We will be going over the next section pretty slowly, just because it focuses more on limits and the math behind the limits. Good luck.